In this lesson, we'll go through a physics problem where we learn how to find the angular momentum and angular frequency. The question reads, an amusement park game consists of a paddle wheel arrangement where you shoot at the paddle with a pellet gun, thereby turning the wheel. So here's the wheel, and let's say that this is a pellet from that gun. The paddle wheel is set in motion with an initial angular momentum of 200 kilograms times meters squared per second and an angular frequency of 4.0 radians per second. So here we have angular frequency, which is the same thing as angular velocity. You shoot 8 40-gram pellets at a speed of 200 meters per second at the paddles. The pellets hit the paddles at the 0.8 meter radius mark and impart all their momentum to the wheel. Find the new angular momentum of the wheel and the new angular frequency. The first thing that I want to do to tackle this problem is to take a look at some important formulas that you will need to be aware of, and they're shown on your screen. So we have the rotational inertia, I is equal to mr to the power of 2, and depending on the movement this formula changes, but in this case that's what we use. The linear velocity is shown below, and you use this to derive the angular momentum formula, being L is equal to I times omega here, which is your angular velocity. I show how you go from this to this in a previous video, so I won't go through it again here. Now with that being said, I want to calculate the initial moment of inertia of the paddle wheel before any of the pellets have hit it. And for that, I can use the formula at the bottom where I have L is equal to the moment of inertia. I'll solve for that times the angular velocity. And the reason why I'm using this formula first is because they've already told us the initial angular momentum, which I'll replace in for L. 200 kilograms times meters squared per second is equal to I times 4.0 will be in place of this symbol. 4.0 per second. Now you don't need to write down radians per second, it's the same thing. So if we divide both sides now by 4, we end up with our original or initial moment of inertia. 200 divided by 4.0, you can do this in your head, it's 50. And the units for this, if you work it all out, should be kilograms times meters squared. So we have the initial moment of inertia. And now the next thing that I want to do is calculate the angular velocity after the wheel has been struck by these pellets. To do this, I can use this version of the formula. So I have L is equal to m times r times v, where L represents our angular momentum, and that's what we're looking for. So the pellets have a mass of 40 grams. That needs to be made into kilograms so that the units all work out, and that's 0.040 kilograms. The radius at which it hits the paddle is 0.80 meters. That's the correct units. And the speed, we were told, is 200 meters per second. That's fast. Meters per second. Now, because it's 8 pellets hitting the paddle, we have to multiply whatever we get here by a factor of 8. So 0.40 times 0.80 times 200 gives us this value. We multiply that by 8. And we end up with 51.2. And the units should be kilograms times meters squared per second, as you would expect for angular momentum, as we had up here. So because we are calculating the new angular momentum and the new angular frequency, what I have to do is combine the original angular momentum with the angular momentum that was contributed by the pellets. So I will add these two values up, where I have 200 plus 51.2 gives us 251.2 kilograms times meters squared per second. And that represents our new angular momentum. And to calculate the new angular frequency, or the velocity, I'll use the formula. L is equal to I omega. And I'll replace 251.2. And I'll ignore the units because I know what the final units are going to be anyway. And we're looking for this value. And in place of I, we will take this value that we found earlier, the initial moment of inertia. So this is I sub I, let's say, and add to it the moment of inertia of the additional mass from the pellets. So that requires a separate calculation. I is equal to the mass of the bullets, which was 0.040. Multiply that to the radius, and that was 0.80 raised to the power of 2. Then whatever we get here, we multiply it by 8 because of the impact of 8 bullets. So I'll take this, multiply it by 0.80 to the power of 2, and multiply that by 8, and we get the following value of 0. Let's say 2. And if we want this to two significant figures, we can write down 0.20, add it to 50, and if you add those together, you get 50.2, and now we can solve for omega, which is our brand new angular velocity or frequency. 251.2 divided by 50.20, and we end up with a value of 5 radians per second. If you want this to the correct number of significant figures, you can write down 5.00. And there you have it. That is how to find the angular momentum and angular frequency.